Oop, there we go. I bet that's Noah. Other Noah. Yeah, other Noah. I was gonna say you were at all your other ones. Figured you'd be here because you don't get to play if you're not at school. So I always keep eyes on everybody else's other peers to make sure we not just keep in mind. Sweet, sweet. It's here. There we go. Awesome sauce. Got it all fixed. All right. So we're on page 39. And we're going to be looking at, this says, how does the solution change? We're asked to do this without solving as much as possible. If we need to plug in and solve, I'd rather we plug in and solve than not do it. But we also probably can do this without solving, without doing it. So what we're looking at here is what's going to happen to x if a gets bigger. So a is a thing. If a gets bigger, what's going to happen to x? So on this first one, it says x minus a is 0. So if a gets real big, what is x going to do to make it still equal 0? It's going to also have to get bigger. So you guys have way more space to write. I just smoosh it all together. If a gets big, x will have to get just as big. Because for this to work, for x minus a to equal 0, x and a are going to have to be the same thing. Then let's look at b. If a gets really big, and a times x equals 1, what's going to happen to x? Or, yeah. If a gets real big, we got a, big A. What's going to happen to x? It's going to have to get real small. Bitty. So that a times x equals 1. So if a gets big, x will get very small. Here there's something called inverses. What that means is x would have to be 1 over a. So this would be one of those ones that you could plug in and test it. If a is 2, x would have to be 1/2 to make it equal 1. If a became 4, x would have to get even smaller, down to 1/4. If a went up to 10, x would have to be 1/10, even smaller. So you can plug in values to test it. And this is one that sometimes it helps us see that. So there's nothing wrong with plugging in values. It's good math. It's doing the process. We're just also trying to make it a little bit more abstract so that we can think it without having to plug in the numbers. Because if we only plug in the numbers, it's going to make some things harder. Okay? So then we're going to look at C. We've got a times x equals a. So if a gets really big, what's going to happen to x? What would x have to be for this to work? Let's see. When in doubt, plug in a number. So pick a number for a. 2. 2 times something equals 2. What does x have to be? 1. All right, let's make a bigger. Something bigger than 2. 30. 30 times something equals 30. What does x have to be? 1. So does x change as x gets really big? Or as a gets really big? No. X won't change here. Because this only, whoa, what is that handwriting? Holy cow. Because this only works when x equals 1. X has to be 1. X can only be 1. Anything else won't work. Okay. Last one on this page. We've got that x over a equals 1. So as a gets really, really big, what does x need to be for that to still equal 1? So we have big A. What's going to happen to x on top to make it still equal 1? It's going to have to be the same exact thing. It's going to have to be big X. So when in doubt, sometimes with these, if I'm just looking at sizes, I'll take the teeny tiny a and I'll make it a big fat A. And my teeny tiny x make it a big fat X. Sometimes the visualization of it's all it takes. So as a gets bigger, that's not how we spell gets. There we go. X also has to get bigger. In order for this to remain true, and no, I heard you notice it exactly right, they'd have to be exactly the same value. So if a is 2, x has to be 2. If a becomes 30, x has to be 30 for it to still equal 1. If a becomes 1,000,000, x has to be 1,000,000 in order for it to be 1. So no matter what happens to a, x has to get bigger. So we're just trying to look at that equation and try and read pieces off of it without having to solve problems. We can. We've got the skills for that, but we don't always like to. It's not always easy. So, questions on this page. It's a little bit more abstract. Okie dokie. Oh, it still did put those in things. So the next thing we're going to do is we're going to jump to page 42. Because I don't know why, but I always forget to move this page in front of the stuff we talk about on the card sort. I always forget that. So we're going to be on page 42. And this is going to be significantly more familiar, mathy-wise. Because we're going to have things that are like equations. We've got that a store sells 2 brands of headphones. We've got a high definition and basic. They buy some number of high definition headphones at Z dollars, some dollars, and Y number of basic headphones at W dollars. What we're going to do is we are just writing the equations here. We're not solving. We're just writing the headphones. Equations about the headphones. Not just writing the word headphones. So what they're going to do is they're going to give us pieces about the headphone situation. They've even given us several variables here. We've got W dollars for basic headphones and Y number of basic headphones, and then we've got Z dollars for HD headphones and X number for HD headphones. So we've got 4 letters here. And we're going to fill in some of those here and try and write some equations. So what we're going to write is we're going to write an equation for the number of basic headphones the store can buy if they spend $10,000 on headphones and they buy 110 HD sets. So the first thing we're going to do is kind of match up what we know. I know they're going to buy 110 HD headphones. That is what I've got up here highlighted in pink. That's going to be in place of our X. Oh, I hate that. Don't do that. There we go. I know that the HD headphones are going to cost $70. That's what they had as our Z up at the top. We also know it's going to have a total of 110, or of 10,000. I'm really not reading well today. So how can we put this together as an equation? What do we know? It equals 10,000. When in doubt, found our total and put that to one side. It's going to equal $10,000. Let's take our HD sets and let's figure out what we can do with them. What can I do with the fact that they're purchasing 110 HD headphones at $70 each? How much are they spending on HD headphones? Yeah, 110 times 70. How many they're buying times how much they spend, right? So this is our total. This is our HD headphones. What do we know about our basic headphones? Do we know how many they're going to buy? No. So we can use a variable. And they already gave us one of those. It's going to be the Y. Do we know how much they're going to cost? No. Because of course not, because they didn't give us any information. So what are we going to put? Times W. We take the number of headphones times the cost. So we're going to take the number of headphones times the cost. So we're going to take the Y times the W, and that tells me all about my basic headphones. What are we going to do to combine together our basic headphones and our HD headphones? Add them. So in between, we're going to put a plus, because we're going to take our basic headphones and everything we know, combine them with the HD headphones for our total. And we don't have to go any further. If you did notice that 70 times 110 gives you 7,700, great. Absolutely fine to multiply it out. Totally fine. You don't have to go any farther than this, though. We're going to do the same thing for the next two. Okay? So see if you can do B. Actually, no, we'll do B together, and then I want you to see if you can do C. Okay, we'll do B together to practice it one more time, then I'll give you some time to work on C, and then we'll talk about it. Okay, same process. We want to write an equation about the price the store is going to pay for HD headphones. It's going to spend a total of $2,000 on headphones. It buys 55 basic headphones for $20 each. So new situation, like it's not tying back to A. So we've got a new total. And we've got this time information about our basic headphones. So how are we going to build this equation? So we've got our... Just highlighting our variables so we can see them again, because it's a big old wall of text. So we know that it's going to equal 2,000. That's my total. What else do we know? Yeah, they're going to buy 55 basic headphones. So how much are they spending on basic headphones? 20 each, right? So what are we going to do with the 55 and the 20? Times them together. How do I add in my HD headphones? Because I need information about them. Yeah. However many HD headphones we buy, which we don't know, so we're going to call it X, times however much they cost, which again, we don't know because they're not being super helpful for us. We're going to call it Z. I always put a little crossbar on my Z, otherwise it starts to look like a 2. That's the only reason I do that. Because my Z's and my 2's are shockingly close. So that's all the little line is on my Z. It's just to make it real clear that's a Z. And then we take our basic headphones and we take our HD headphones and we combine them together. Okay? So I want you guys to try and do C. Try and write your own equation for C. Being able to find the pieces of an equation, whether or not we're solving, is a really important piece. So try and write your own equation for C. I'm going to give you guys like 5 minutes for that. Okay? Try and write your own equation. Ask questions if you need to. Like, I'm super happy to help you. Let's go. All right. What are we thinking? What did we get for some sort of equation? Eight times 80. That's talking about our 8 basic headphones for $80 each. Plus X times Z equals our 800. I'm with you on that. What's up? So we've got up here in the paragraph, the X is however many HD headphones. It's right here. It buys some number of HD headphones. And the Z is the dollars of how much they cost. It feels super awkward because we have too many dang letters in it. Like they do too much sometimes. We are not going to ever have to solve a system of 4 variables. Like they tossed a whole lot at here. They could have 100% done this with 2 letters. But they are extra with extra E's on the front. Extra. This book likes to make choices sometimes, but we're going to we go with it anyway. So we'll start working with these equations, start solving them really when we start looking at these again next week. We'll look at the next page, which talks about buying a car and sales tax and things that are very, very relevant in real life. And we'll start working with some of these equations and working more towards the solving side of them. The writing of the equations themselves is definitely the hardest part when we're looking at problems like this. The finding of the pieces in the paragraph and figuring out where the heck to put them. That is the hardest part, 100%. And that is valid, and that is normal. It is normal for this to be hard to find the pieces. It's one of those things that takes practice. If you can find all those pieces and it is not super hard for you, excellent. If it's hard for you, please understand that that is incredibly common. And that's why we have homework, and that is why we have time to practice these, because that's hard. Okay? So, homeworks 2.1 and 2.2 are the ones we have done so far in Chapter 2, in Unit 2. This chapter only has, I believe, 3 homeworks anyway. So, I'm just looking for. Yeah, it only has 3 homeworks. So we've done 2/3 of the homework in this chapter. Okay? Just so we're aware, the next chapter has significantly more homework. I want to say there's 9. But it's longer. So we're still going to average about 1 a week, but this chapter there's like 1 every week and a half, so that's how it's going to average out. Okay, so please make sure you do those homeworks. Again, they're not assigned to be cruel. They're easy points because you can do them as many dang times as you want. And we'll auto grade for you so that you can get that feedback right back. So you can practice it, practice it, and practice it as needed. And send me questions if you have them. Yes, dear. Yes, dear. Okay, so use this time, catch up. They're on Canvas, so you can like do them on your phone. It's not easy, but you can. That is fourth period. 98207. They go, dear.
Thank you.
Mm-hmm.